If we stack the lifespans of everyone alive today, we get an average of roughly a century. 100 years feels long to us, yet on Earth's timeline it barely qualifies as a blink. Think of the attention we give to a single second in our own year. Earth gives that same level of importance to tens of thousands of years. Our planet has existed for about 4.54 billion years and will survive for hundreds of millions more. If we compress Earth's entire history into a single day, humanity shows up only in the last 2/10 of a second before midnight. We can't see even the next second of that cosmic day, yet physics lets us predict much of what's coming. Take the massive buildings we admire. They look solid and permanent, but they are temporary guests on Earth. Concrete survives only a few centuries before its chemistry weakens the structure. If there is poor maintenance or too much metal inside, corrosion takes over and the whole thing crumbles within 1,000 years. Steel bridges suffer the same fate. In a few centuries, their skeletons give in to rust. Even stone is fragile on long timescales. The granite faces carved into mountains will erode grain by grain. In a handful of millennia, even iconic sculptures carved into rock will flatten into dust. Our towers and monuments are seasonal decorations compared to the planet's slow clock. Consider a place like Chernobyl. The name still echoes fear, but the story today is very different. Wolves, boars, and wild horses now roam freely through that zone. Since people left in 1986, biodiversity there has risen dramatically. Radiation is dangerous, but the stubborn fact is that human presence is often a greater threat to ecosystems. After a few centuries, the dangerous isotopes will decay away. Forests will reclaim the land, reactors will vanish under roots and soil, and in a couple thousand years, the region will look unremarkable. Chernobyl is a preview of how quickly Earth heals when we step aside. Now take the rhythm of Earth's rotation. It is not a perfectly steady spin. It wobbles in cycles linked to the way our planet tilts and orbits the Sun, patterns known as Milankovitch cycles. Every 10,000 years or so, the northern hemisphere drifts slightly farther from sunlight. When that happens, thick ice sheets begin to grow over northern regions, lowering sea levels worldwide by dozens of meters. The coastlines we know today would shift far inland, and the mild climate that nurtured human agriculture would fade into long cold phases. The planet would return to a world of winter. Even waterfalls change the planet's face. Each year the waterfall cuts backward by about a meter. In 1,000 years, it will retreat all the way to the lake that feeds it, and once the water drains freely without a cliff, that iconic waterfall will cease to exist. A postcard scene celebrated for generations will someday become only a memory. Stretch a few thousand years more and the continents themselves begin to drift noticeably. They move as slow as fingernails grow, just centimeters per year, but over long time they shift entire worlds. The western coasts of the Americas drift northward, Africa inches toward Europe, and the sea between them continues to shrink. In 1,000,000 years, the inland sea then may disappear entirely, replaced by mountain ranges as tall as today's Himalayas. The world map we memorize in school is not a fixed picture, it is a breathing thing, changing so slowly that our short lives barely register it. Think about the enormous volcanic system beneath Yellowstone. It is a supervolcano that erupts roughly every 100,000 years. The last eruption was more than 600,000 years ago, which means the system is overdue on geological scales. If it erupts again, volcanic ash would blanket an entire continent, cooling the global climate for years. Ecosystems would collapse and rebuild, and life would adapt again in new forms. The same ash that destroys also enriches soil, allowing forests to return centuries later. Destruction is followed by renewal, and the cycle repeats endlessly. Even the tides will change. As the moon drifts farther away, its pull weakens. In 1,000 years, the shift will be small but noticeable. In 60 million years, the moon will be too distant to cast a perfect shadow during a solar eclipse. Tides will shrink, coastal ecosystems will transform, animals that rely on tidal rhythms will evolve or disappear, nights will grow slightly darker, and days will stretch a little longer. Look up at the stars. The constellations that guided ancient travelers are not permanent designs. The stars move slowly across the galaxy, and in a few thousand years the familiar patterns will warp. The hunter's belt will bend. The 7 bright stars we call a major constellation will stretch out like rubber, and the guiding pole star will shift from one bright point to another. A future sky watcher will trace new myths across the heavens entirely different from the ones we inherited. The sky is not a fixed ceiling, it is a slow ocean of drifting light. Jump ahead 25 million years, and the Atlantic Ocean might no longer exist. Africa and Europe will collide with the Americas as the continents continue their long cycles of drifting apart and pulling back together. Species that evolved separately will meet again, climates will blend, and habitats will rearrange. Meanwhile, Australia is drifting toward Asia and may one day crash into it. Eventually, the continents might merge into one giant landmass near the equator, a future supercontinent. Its center would be an enormous desert with temperatures well above 50 degrees Celsius. Fewer coastlines would mean weaker ocean currents, lower oxygen levels, and another wave of extinctions. Yet even then, life would return in new shapes suited to the new world. Mountains erode too. The Himalayas rise a few millimeters each year, but wind, rain, and ice remove that growth just as fast. Over millions of years, peaks shift, crumble, and flatten. Even the tallest mountain on Earth will eventually wear down and return to the plains, while new mountains form elsewhere. Earth is a sculptor always reshaping its creations. Far in the future, the sun's brightness will rise by about 10% every 100 million years. In 500 million years, Earth's temperature will climb by around 10 degrees. Oceans will evaporate faster than rain can replace them, turning water vapor into a powerful greenhouse blanket that accelerates heating. Global warming will push past anything humans could ever trigger. The seas will shrink, carbon dioxide will plummet, and only hardy bacteria and algae will survive. The grand flourish of complex life that began hundreds of millions of years earlier will wind down quietly. In 1 billion years, the oceans will vanish completely. The surface will transform into a scorched desert, with daytime temperatures soaring above 100 degrees. As clouds disappear, Earth will lose its familiar blue and fade into a dusty world. Eventually, as the sun becomes a red giant, the atmosphere will burn away, the surface will melt, and everything we know will turn to vapor. Yet the atoms themselves do not die. They drift outward into space, fall into the sun, or help form new planets. The same elements that built every creature on Earth will glow again in other skies. That is the universe's version of immortality, not of species, but of particles. And beyond all this, galaxies themselves will change. The Milky Way will merge with the Andromeda Galaxy, forming a single swirling giant often called Milkdromeda. By the time this cosmic merger completes, our Sun may no longer exist. But somewhere else in that vast new galaxy, or in another corner of the universe entirely, an intelligent species might be staring upward, wondering how the cosmos will change after they are gone. Our story might end, but the universe keeps writing new chapters forever.